The fetch-execute cycle. Like any machine, the CPU can carry out several functions or operations. The type of operations a CPU can perform include arithmetic, data movement, condition testing, bit manipulation, and other logical operations. The CPU performs its operations in response to instructions it receives from an executing program. These instructions are coded, and the complete set of instructions recognized by a CPU is called its instruction set. Instruction set sizes vary from a few dozen to a few hundreds, at most. The instruction set should at least have instructions to perform addition and complementation, or negation, on unsigned and 2's complement numbers in registers. Most can perform comparison, subtraction, multiplication, and integer division. Modern CPUs can also handle floating point numbers as standard, performing a variety of floating point arithmetic and trigonometric functions. Bit operations, such as left and right shifts, as well as not, and or operations are also common instructions found in the instruction set. The CPU should also have instructions to move data between memory and its general-purpose registers, as well as from one general-purpose register to another. Modern CPUs can even transfer data from one memory location to another directly. The CPU can also be told to execute instructions starting at a specified memory location. The CPU will continue executing instructions in sequence until told to transfer control to some other location. Such control transfer can be made conditional on the state of one or more flags in the status register. For example, the CPU may continue execution from address 1000 if the 0 flag is set. Finally, the CPU must be able to read and write to I/O devices. The procedure of executing one instruction in a program is known as the instruction cycle or the fetch-decode-execute, or simply fetch-execute cycle, and basically consists of the following steps. Fetch instruction: read the instruction from the memory location specified by the program counter. This instruction is stored in the CPU's instruction register. Decode instruction: decode the instruction and fetch any data required by the instruction from main memory. Update PC: increment the program counter to point to the next instruction in sequence, that is, add the length of the current instruction to the address in the program counter. Execute instruction: activate the correct circuits for performing the operation indicated by the instruction. End of cycle: go to step 1 and repeat the cycle. This sequence of steps is initiated and coordinated by the control unit. The length of an instruction is always an integral number of bytes or words. On modern CPUs, all instructions are the same length, thus simplifying the fetch-execute cycle, but is wasteful of space. Older CPUs had instructions of variable length, which were more space efficient. However, since memory size is no longer an issue, these are less common today, as the fetch-execute cycle is less efficient. An instruction is composed of several parts called fields. Each field is a fixed number of bits long. The opcode, or operation code, indicates the operation to be performed by the CPU. The number of bits reserved for the opcode determine the number of distinct operations which can be coded in an instruction. For example, in 6 bits we can code 2 to the power of 6, or 64, distinct operations. The address mode field indicates to the CPU the type of data to be used by the instruction. This is also called the addressing mode. An instruction may include 0 or more operands which represent data to be used by the instruction. For example, if the instruction specifies an addition operation, then the value or values to be added must be supplied to the CPU as operands. If, on the other hand, a left shift operation is to be performed, no operand is required and the CPU can start the execution of the instruction. Thank you for watching.